As you might know, trigonometry is all about solving triangles, particularly right-angled triangles, which we'll mainly use here since most triangles can be converted into right-angled ones. We tend to use them in engineering as it's the easiest way to solve problems. As we progress through these lessons, I will refer to different parts of the triangle by specific names, which are commonly used in trigonometry. You might find other names for triangle parts in various mathematical contexts, but we will stick with these. The longest part of the triangle is known as the hypotenuse, which is always the longest side. A triangle consists of three lines summing to 180 degrees, with the longest being the hypotenuse. We consider only one angle at a time in trigonometry, but we know the other angles because we have a right-angled triangle. There is always a 90-degree angle, typically in the bottom right-hand corner of the examples. The other two angles share the remaining 90 degrees, which total 180 degrees in a triangle. Unlike other shapes such as circles, squares, pentagons, and hexagons, which all have 360 degrees, a triangle is unique in having only 180 degrees, with 90 of those taken up by the right angle. Knowing one angle of a right-angled triangle automatically reveals the other angle by subtracting it from 90. When discussing unknown angles, we can name them often using the Greek letter theta. We refer to the length opposite the angle as opposite, and the length adjacent to it as adjacent. When we subtract from 90, we find the opposite angle. Therefore, our shortest side, previously known merely as side, is now called adjacent, because it's adjacent to the angle, and the last side is opposite because it's opposite the angle. The descriptions and names used for parts of the triangle change depending on our reference angle and which angle we use when applying sine, cosine, and tangent, always working from a specific angle. If not, we would be using Pythagoras' theorem, not trigonometry. I'm reviewing these basics, which we likely covered years ago in school, because they are crucial for understanding trigonometry. We use these conventions to solve problems using trigonometry, where the sine of an angle equals the length opposite divided by the hypotenuse. By simply entering the opposite length divided by the hypotenuse into a calculator and pressing the sine button, we can determine the angle. However, if we don't know the opposite length, but know the lengths of the adjacent and hypotenuse, we use the cosine. If we know only the opposite and adjacent lengths but not the hypotenuse, we use the tangent. As long as we know two aspects of the triangle, either two lengths or a length and an angle, we can determine the rest using trigonometry. Before we dive into practical examples, we need to learn how to remember when to use sine, cosine, and tangent, which will be covered in the next lesson. One major challenge in trigonometry is recalling the order of our equations. In a previous lesson, we learned that sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. To remember these, we might use mnemonic phrases like "some old hippies caught another hippie tripping on acid," which helps recall "so caught toe," a mnemonic for sine, cosine, and tangent equations. These phrases make it easier to remember the correct formulas during tests or practical applications. Choose a phrase that sticks in your mind and use it to recall the equations when needed.